Hello, hello. Welcome to the second episode of DataBytes. You might be wondering what a DataByte is. It is a bite-sized conversation with data science and data engineering professionals about structured data and the state of data science today. We have with us today Praveen Balaji, who is a senior software engineer at Diffbot. Thank you for joining us, Praveen.
Thank you, Mara.
Yeah. And so I think Praveen could do a much better job of introducing himself than I could. Could you tell us a little bit your professional bio?
Sure, yeah. Like I said, I'm a senior software engineer at Diffbot. I'm responsible for a lot of the RESTful services which allow users to access the knowledge of data that's available. I've been doing some variant of this for the last 20 years or so.
Wow.
That I've been working, and it's in the last 6 or 8 years that I made this very conscious shift from just generic software engineering to machine learning and data science oriented software engineering, which I really took a liking for about 5 or 6 years back. So yeah, here I am at Diffbot.
Nice.
I like what I do here. Yeah.
That's awesome. Yeah, so what was it that brought you into the world of data science or data engineering more so?
As it was, my career was actually growing alongside the evolution of this whole data science and the big data technologies. But at some point when, this realization struck me that machines have the ability to learn from this large gold mine of data, that's when it tipped the scales for me. And I like I said, very consciously picked up and got into this area of machine learning specifically, which is, of course, backed by data science and data engineering.
Yeah. Ton of opportunity for sure.
Yeah.
What do you like most about working with data?
Well, I think it's a fairly well recognized and widely acknowledged fact that the evolution of large-scale data engineering has enabled machines to learn at scale. Go from research, from the research domain into practical software applications. So that was a big draw for me.
Yeah, Diffbot's sort of at the intersection of that. I mean, this next question I had is sort of Diffbot specific, but we obviously work with automated knowledge bases or knowledge graphs at Diffbot. In a strict sense of the word, what are your thoughts about automated systems actually being able to provide knowledge?
So in my view, I think the problem, automating the construction of the knowledge bases and knowledge graphs is a related but a different problem from systems actually providing knowledge. These are both difficult problems and both worthy problems. And the more you discuss about this, at least some of the discussion around these problems can devolve into a sort of like philosophical chatter.
Yeah.
But by training machines to interpret the internet with the same signals that we as humans would use, Diffbot takes this very practical approach to solving both these problems. Like I said, I view them as two related but different problems. And one is that machines are capable of automation at scale. And the second is that a human-like interpretation of the internet is a precursor to providing a variant of what we call as knowledge that is relevant to humans.
Yeah.
So that's how I, look at this problem of automation of knowledge bases.
Gotcha. Yeah, that's a great answer. At the I mean, it's a semantic difference, information and knowledge. I mean, information tailored to human needs is getting closer, for sure.
Yeah.
Well, cool. So if you had one rule or quote on how to think like a data scientist or professional, like could be a famous person, could be your own role, what would it be?
Well, as a software engineer, I was, at some point I became very acutely aware to the fact that data science and machine learning have evolved out of the realms of academic research into practical application, right? There are tools available to every software engineer, and it's available in every software engineer's toolkit. And we shouldn't be shy of using these. We need to take the glamour out of data science out of machine learning and make it more ubiquitous in
Cool.
software engineering itself.
Got it.
So
Yeah,
I
yeah.
don't have a quote. I don't think Beatles said anything about data science. So
Yeah. Fair enough. Fair enough. Um, yeah, another funny question. Maybe you have one data tool on a desert island. What is it?
this one should be easy. I think it's Redis. Redis has always been my go-to tool.
Okay.
It's sort of a Swiss Army knife.
Yeah, yeah.
I also like the fact that it's the problem that it's trying to address is very well defined. It does what it promises to do, and it does it exceptionally well. So from that perspective, I think it's also a great case study in how software should be designed.
Interesting.
So yeah,
Yeah.
definitely Redis.
Gotcha. What's the biggest frustration that you see, either personally or sort of larger scale, dealing with data today?
I don't particularly get frustrated by things, but I think a lot of software teams use data science and machine learning as glamorous tags. I have worked for a few companies in the past who, for exactly this reason, that I wanted to work in the space of machine learning, and I've noticed that there are a lot of problems in the way these problems are interpreted. They're sort of interpreted to fit the mold of data science and machine learning, where some problems genuinely and legitimately require data science or machine learning to solve those problems, but some of them just don't. So I think it's there's also this problem of what I call data graves, where data goes to
Okay.
die. So maybe that inefficiency is a little frustrating for me.
Interesting. So data that is underutilized, that's sort of siloed off on its own, is that what a data grave is essentially?
A data grave, yeah, both, because just because you have the ability to collect data, just collecting as much data as you can, that's one thing, because hey, you're a data science team, right? Labeling a team at data science immediately sort of puts this onus on the team to grab as much data as they can and count the team's output in terms of the terabytes of data that they're crunching or the petabytes of data that they're crunching. Or collecting, if you will, but also just not having a game plan for what you want to do with this data.
Okay.
So the data then just goes to die in the silos that are built to hold them.
Gotcha. A sad situation.
Yeah.
But so what change or trend in this last? I mean, you said what 5 to 8 years, maybe within more data centered role. What is there any like one change that's been amazing over that period, or you found very cool?
Yes, this again goes back to at least two of the things that I have said earlier. One is just the enablement of machines to learn from large corpuses of data. And this was actually, in my opinion, enabled, and I also think it's a fairly acknowledged fact that it comes from the improvements in hardware, it comes from improvements in software, and also the algorithms that have been developed in the last, couple of decades, at least in the last, especially the changes that have come through in the last couple of decades, have enabled machines to learn from these large corpuses of data. And the second thing, I think, and this has always been a big thing for me, this fact, or this realization of the fact that data science and machine learning have evolved out of the realms of academic research into general software engineering. And I, being a software engineer and not a researcher, find that every software engineer needs to embrace this, needs to use these things as if they were tools in their toolkit. You wouldn't use a hammer for everything that you wanted to do, but also you don't call yourself a hammerist, right? You are a carpenter, or you are. So being able to recognize that, taking out the glamour out of these fields, and I say that in a nice way. I mean, once you take out the glamour, you actually see for real what those fields are, and being able to honestly apply them in software engineering. I think these are the trends that or changes that I really like, having seen the last few years.
Gotcha. And there's probably a lot of power in that. Like historically, there was more of a divide between practical computer science and research, right? And being able to like reach in and say, I can learn from this academic paper as somebody who is working on a very practical problem, right? That interplay is probably powerful. Opens up a lot of opportunity. Which is really our final question here is, what do you see as the biggest opportunity in data at the moment?
Well, for me personally, I think the biggest opportunity is in the space of just using data for learning, being able to solve problems that make sense to humans, right? I think that's where the biggest opportunity is. And I have, again, I've very consciously tried to move my career along those lines, that I choose to work with companies that are solving difficult problems in the space of using data to make to build practical solutions that make a difference for humans.
Totally.
So that I see that area as largely as the biggest opportunity, and a lot is available to be tapped in that area.
Yeah, it's a great answer. And yeah, I love to focus on clamor throughout a lot of these. Like if we can get past the hype, right? And we could, it's like, okay, we collected all this data. Now, how do you connect it with human problems? Totally, super important. Well, awesome. So those are our questions for today. And thank you so much for the insightful answers, Praveen.
Thank you, Mara. It was fun talking with you. I think all these were really fun questions. I really enjoyed that.
Oh, great. Well, thank you so much.